You've gone a full day without talking to another human being. Maybe it happened on purpose, maybe it just happened. Either way, by the end of that day, something in you started to feel a little off, and you probably couldn't explain exactly why. Now imagine that day stretching into a week, then a month, then longer. What actually happens to a human mind when the people just disappear? Not physically, just from your life. No conversations, no touch, no faces, just you, alone, for as long as you can stand it. The answer is stranger, faster, and more disturbing than most people expect. And once you understand the mechanism behind it, you'll probably never look at a quiet, empty week the same way again. Start with something simple. Humans are, biologically speaking, built for contact. Not as a nice-to-have, as a requirement, almost as basic as food or sleep. And the researcher who first proved this in a way nobody could ignore was a psychologist named Harry Harlow. In the 1950s, Harlow ran experiments with infant rhesus monkeys. He wanted to know what a young mind actually needs to develop normally. So he raised some monkeys with two fake mothers. One was made of bare wire but held a bottle of milk. The other was covered in soft cloth but offered no food at all. Which one do you think the babies clung to? Almost every one of them chose the soft cloth mother, even though she offered nothing to eat. Comfort mattered more than food. But the darker part of Harlow's research came next. When infant monkeys were raised in total isolation, with no contact at all, they didn't just grow up a little anxious. Many of them became severely disturbed. Some rocked constantly. Some attacked themselves. Some never learned how to interact with another monkey again, even after isolation ended. That's the animal evidence. But what does isolation actually do to a human brain specifically? A psychologist named John Cacioppo spent decades studying this question at the University of Chicago, and what he found reframes loneliness entirely. Cacioppo discovered that chronic isolation doesn't just make people feel sad, it changes how the brain processes threat. Isolated brains become hyper-alert to danger, scanning faces and situations for signs of rejection or hostility that aren't actually there. In other words, loneliness doesn't just feel bad, it quietly rewires perception itself. Why would a person's brain do that? Here's the uncomfortable answer. For most of human history, being alone wasn't just unpleasant, it was dangerous. A human without a group had no one to watch their back while they slept, no one to help gather food, no one to defend them from predators or rival groups. So evolution built loneliness to function almost like physical pain, not a mood, an alarm. That alarm is why isolation triggers something close to a stress response in the body. Cortisol levels rise, inflammation increases, sleep gets worse, which makes everything else worse. The body starts behaving as if it's under siege, because for most of human evolutionary history, being alone often meant it was. Let's actually walk through a rough timeline of what tends to happen, because the progression itself is revealing. In the first few hours alone, almost nothing happens. Most people barely notice. Humans are used to short stretches of solitude, and in small doses, being alone is often pleasant, even restorative. By day 2 or 3, something starts to shift. Mood becomes harder to regulate. Small irritations start to feel bigger. Concentration gets patchy. This is roughly the point where the brain's threat detection system, the one Cacioppo studied, starts quietly ramping up, even if the person can't consciously feel it happening yet. By the end of the first week, most people report a noticeable drop in motivation and a rise in anxious thinking. Sleep starts to fragment, which compounds everything else, since poor sleep and poor emotional regulation feed directly into one another. Push past a few weeks, and this is where the research gets genuinely disturbing. This is the range where Craig Haney's solitary confinement studies start showing hallucinations, memory distortion, and a fraying sense of identity in a significant share of subjects. Not everyone reaches this point at the same speed. Personality, prior social history, and even genetics all shift the timeline, but the destination, if isolation continues long enough, tends to look remarkably similar across very different people. There's also a more recent, less extreme, but far larger scale natural experiment that shows this pattern playing out in real time. The COVID-19 lockdowns. Researchers tracking mental health data during extended periods of social restriction found sharp increases in reported anxiety, depression, and loneliness across almost every age group studied, with some of the steepest increases among people who lived alone. It wasn't solitary confinement. People still had phones, screens, video calls, but even that reduced, filtered version of connection wasn't enough to prevent the same underlying pattern from showing up, just in a milder form. That detail matters, because it suggests something important. Connection isn't just about the presence of other people somewhere in your life. It's about the quality and directness of contact your nervous system actually registers as real. Now let's take this further, into what happens when isolation becomes extreme and prolonged, in the clearest, most severe version of this research. Solitary confinement in prisons gives researchers a disturbing but very real window into this. A psychologist named Craig Haney has spent decades studying the effects of long-term solitary confinement, and the pattern he documented is remarkably consistent across different prisons and different people. Within days, most people in extreme isolation report anxiety and a kind of mental fog. Within weeks, many begin experiencing hallucinations. Not full psychotic breaks in every case, but real, sensory experiences that aren't there. Some report hearing voices, some report seeing shapes move at the edges of a completely empty room. The mind, starved of external input, starts generating its own. This isn't weakness, it's what almost any human brain will do under those conditions. The brain is built to constantly process a stream of social and sensory information. Remove that stream entirely, and the brain doesn't just go quiet, it starts filling the silence with something, even if that something isn't real. Members and identity take damage too. People held in extended isolation frequently report losing track of time in strange ways. Some describe forgetting the sound of their own voice. Some describe a growing uncertainty about who they even are, because so much of identity is built and maintained through interaction with other people. Without anyone to reflect you back to yourself, the sense of self can genuinely start to blur. Children show this in an even more dramatic way, and one of the clearest examples comes from a very different kind of research. In the 1990s, researchers studying children raised in severely understaffed Romanian orphanages, where infants received almost no social interaction, found catastrophic effects on brain development. Brain scans of these children showed measurably reduced activity in regions responsible for emotional regulation and social understanding. Isolation early enough, and for long enough, doesn't just harm a developing mind, it can permanently alter its structure. So across every version of this research, animal or human, adult or child, voluntary or forced, the same conclusion keeps showing up. Extended isolation doesn't just make a person feel worse, it changes how the brain works. Here's a question worth sitting with. If humans need connection this badly, why does modern life make it so easy to go without it? Because unlike solitary confinement, modern isolation rarely looks like isolation. You can be surrounded by notifications, messages, and feeds all day and still not have a single real conversation. Digital contact activates some of the same reward systems as real connection, just weakly, the way a photo of food can trigger hunger without ever satisfying it. Many people today are what researchers now call socially malnourished. Constant, low-quality contact, almost no high-quality connection. There's a reason for that gap between digital contact and real connection. Face-to-face interaction delivers a flood of information a screen simply can't replicate. Tone of voice, micro-expressions, timing, touch, shared physical space. Your nervous system evolved to read all of that as evidence of safety and belonging. A text message, however warm, delivers almost none of it. So the brain keeps waiting for the fuller signal, and when it never fully arrives, the underlying alarm never fully switches off either. And the effects, while less extreme than solitary confinement, follow the same direction. Studies tracking loneliness in modern populations link chronic isolation to increased risk of anxiety, depression, and even measurable increases in early mortality, on a scale researchers have compared to the health risks of smoking. Isolation isn't just an emotional inconvenience, it behaves like a physical health threat, because to the body, it essentially is one. So what would actually happen if humans, as a species, simply stopped socializing altogether? Based on everything the research shows, the answer isn't a slow fade into quiet solitude. It's closer to a full system malfunction, hyperactive stress responses, rising anxiety and paranoia, hallucinations in extreme cases, a blurred, unstable sense of identity, children failing to develop core emotional and social abilities at all, not a peaceful, self-sufficient existence. A slow unraveling of the systems that make a functioning human mind possible in the first place. Connection, it turns out, was never a luxury layered on top of survival. It was part of the operating system all along. There's an encouraging side to all of this, though. Just as isolation can rewire the brain toward threat and distortion, connection appears to work in the opposite direction. Cacioppo's later research found that even small amounts of genuine, high-quality social contact could begin reversing some of loneliness's physiological effects, lowering stress markers and improving sleep within a matter of weeks. The system that breaks down in isolation is largely the same system that repairs itself once real connection returns. It isn't a one-way door, which brings this back to that first day you spent without talking to anyone. That small, hard-to-explain discomfort wasn't random. It was a very old alarm, still working exactly the way it was built to, the same alarm that once helped keep your ancestors alive by keeping them close to their group. And understanding that alarm might be the most useful thing you take from any of this. The moment isolation starts to feel normal is usually the moment it's already doing the most damage. And the fastest way to quiet that old alarm was never distraction. It was always just being around people again.